Hi, welcome back to CarsAddiction.com. If you're new to the channel, I'm Ryan and we share car-related content every Wednesday and Sunday. Wednesday is a short snippet of any car encounter I come across, and Sunday is a full-fledged video of any project, build, cars that I own, any travel occurrence I come across, you name it, I will share it on the channel. Now this week is all about wheel measurements. Now wheels come in various sizes and formats, and the numbers that are associated with them might come a bit complex, and I'm here to explain the numbers. There are three sets of numbers. One is the general structure, the diameter, the width and whatnot. The other set is the bolt pattern, where the wheel actually mounts to the car, and the other one is sort of related. It's the actual bore, the diameter of that. Now let's use one of the wheels we have in the background as an example, so let's get to it. Okay, so we'll use our Race Engineering wheel as an example. Right over here we have the first set of numbers, 16 by 7J53. Now they can be found in various places on wheels. They could be over here or in the back or in one of the spokes or as a sticker or nothing at all. So it really depends on where the wheel is coming from. But for this one we have the dimensions here. What do those mean? Now the first two numbers are measured in inches and the last number is millimeters. Now what the first number means is the diameter of the wheel. But there's one issue. So if we actually measure from tip to tip diameter, we get more than 16 inch, we get actually 17 inch. That's because the 16-inch number is where the tire sits. So the tire is not sitting exactly with the edge of the lip. It's actually sitting somewhere in between, over here. And that will be measured 16-inch on that thing. That is measured, sort of to speak, not from lip to lip, but where the actual tire intercepts. Now that I mentioned that, then we go to the second number. The second number is actually the width of the wheel. And again, it measures from inside the barrel where the tire sort of sits. Obviously, it's hard to measure when there's a tire on things, so we're going to be using another wheel. So here we have another wheel. If we see the numbers, that's BMW, because this wheel is a BMW. CDW is the manufacturer that does the wheel for BMW. That's the part number, and over here we have 8.5 and 17, because this is a 17-inch rim. So again, like in our previous example, if we measure that's around 18 inch, but because we're measuring from lip to lip using the wrong thing, that's where the tire sits. And it's more or less 17 inch where the tire fits. Now the 8.5J is the width of the barrel. So again, it's where the width of the barrel where the tire sits. So if the tire sits somewhere over here, and up there, that's 8.5J where the mark is coming up from. Now the last number of this batch is the offset. Now generally speaking, it could be a number of its own, or it could have the prefix IS or ET. So what does the offset actually mean? So we have the center of the barrel. A positive offset will be meaning that the mounting point, which is right over here, is 50 milliliters outwards of the car. Okay, and then we have a negative offset where that mounting point is more inwards. So you can imagine that if we had this at a zero offset, we would already have gained a 50 milliliters of lip. So we'd have gained that much of lip. If it was much more negative, we'll even have a larger lip. Now, what does that do is move the barrel towards the suspension or towards the fender. The problem with negative offset, imagine this will stay as is and we'll push this towards the outwards of the car, which will hit your fenders. So that's the problem of having an aggressive negative offset. If you have an aggressive positive offset, you have risk of hitting the suspension and rubbing right in there. So you have to find a balance in between. Now, we can play actually around with the offsets if we don't want to change the wheels. In this case, we can use the spacers. As you can see, this wheel is so inwards of the fender gap, so it could benefit of actually having an aggressive negative offset wheel. But to play around, if we don't want to buy new wheels, we can have put offsets over there to push the wheel outwards more towards the fender. and it's a bit tricky to get a good balance in between. But if you do your homework well, you will get good results like what happened with our 260Z. Now, what you want to do is go on the website Will They Fit and input your standard wheel sizes and compare them to the wheels you want to get. And the website will give you the difference of the new wheel with the original wheel. And you be able to take a ruler and measure the distance roughly to see if you're going to be hitting or not. Now don't forget, when the wheel is on the ground, it sort of cambers a bit. So you'll have to take measurements loosely because they're not so easy to take. The next group of numbers is the PCD, the bolt pattern. Now, they are actually two numbers. You have the first number, an X, and the second number. The first number is how many bolts you have on the wheel. So 1, 2, 3, 4, 5 in this case. So this will be 5X. You could have 4X, you could have 6X, and so forth. Now, the other number is measured in millimeters and is the diameter of where the bolts sit. So imagine you have an imaginary line, just draw an imaginary line in the center of the bolts and measure the distance of the diameter. So this is a 5x100 wheel. So as you can see, we have 100 over there, 10 centimeters times 10 to make millimeters, and that's 5x100. Now, there's an exception where you have wheels such as this. So this is a 5x114. If you draw an imaginary line, it is on the 114 mark. But you might be wondering why it's 5 stud and not a 10 stud. Well, the design of this wheel, they made it that the wheel can be put into various positions just to make it look nicer. So ignore this and don't make it as a 10x114 because the actual stud pattern goes to the car and not to the wheel. So this is a 5x114. That's a 5x100. We have a 5x120 over here. Again, that's measured from the center of the bolts and the imaginary line, and we come over there. Now, manufacturers like to keep the same bolts between cars, but don't stay 100% on them because they might differ. So the stud pattern is crucial if it will fit onto your car or not. If you have a different stud pattern, there are these adapters, but what would that do is increase your offset because there has to be like a plate in back just to convert the PCD. So it's not really recommended. You should actually get the right PCD straight off the bat. Now the last measurement is the bore center, which is over here. So usually on the hub of the car you have something protruding out, and that will prevent having a small bore fitting onto the wheel. If you have a larger one, that will fit in no problem at all because it will be held by the bolts. Might not be good for high speeds, and for high speeds what you do if you have a larger center bore, you put a sort of a spacer in between to make that snug. Now this is measured again in the diameter way and is measured in millimeters. So the problem is if you have a larger bore hub on the car into a smaller bore onto the wheel. In this case, you need to take the wheel to a machine shop to make this larger. Usually the difference is not that large and you have a lot of gap where to play for, and they'll be able to do it for you. So to wrap it up, we talked about the diameter, the width of the wheel to take larger tire sizes. We've talked about the offset that goes closer to the fender or away into the spring. Then we talked about the PCD pattern, and we talked about the center bore. As a bonus, I'd like to mention that there's also center lock wheels. They just take one extra bolt, but they actually have a bolt pattern in the back as well. But that's a bit more complex and not so common used on street cars. I do hope you like this video, and if you like what you watch, please subscribe. Thank you for watching. Take care.